All right, example 3 is a mixture problem. Um, these are just a little bit different from the other problems. All right, it says a pharmacist needs 100 liters of 50% alcohol solution. She has a 30% alcohol solution and an 80% alcohol solution, which she can mix. How many liters of each will be required to make the 100 liters of a 50% alcohol solution? All right, so again, we have two things that we're talking about here. We have a 30% alcohol solution and an 80% alcohol solution. And we want to know how many liters of each will be required to make 100 liters of a 50% alcohol solution. All right, so we will let X be the 30% solution and we'll let Y be the 80% alcohol solution. All right, so together we need 100 liters. So the amount of the 30% plus the amount or the number of liters of the 80% is supposed to equal up to 100 liters. All right, so I call this the basic equation. So this actually is a little similar to example 2. And then the other one will be the one where you put the units in. So this is X is a 30% solution, so you write 30% as 0.3 as a decimal, or 0.30. And you write 80% as 0.8. All right, and then I want 50%, 100 liters of a 50% solution. So that is going to be 0.5 times 100. All right, so you have your basic equation, then you have your unit equation. We can do substitution, we can do elimination. How about we do elimination on this one? All right, so I'm going to multiply. If I want to get rid of the x's, the LCM would be 0.3, so I'll multiply the first equation by a negative 0.3 so that we have opposite signs. So negative 0.3x minus 0.3y is equal to a negative 30. Multiply by 100, you move the decimal point 2 places. So that is now my equation 1. And that would be equation 2. And I just multiplied 0.5 times 100, move your decimal point 2 places, and you get 50. All right, so now I can add these two equations, and the x's will cancel out. So I get 0.5y is equal to 20, and divide both sides by 0.5, and you get y is equal to 10. Not 10, 40. Okay. Yes, because it's 20 divided by a half. Let me do it right here. All right, so if you take 20 and you divide it by a half, that's the same as 20 times 2, which is 40. So sorry about that. Okay, so now we want to plug this back in. I'll plug it back into equation 1. Which is x plus y equals 100. So that'll be x plus 40 equals 100. subtract 40, and you get x is equal to 60. All right, so that means we have 60 liters of the 30% alcohol solution and 40 liters of the 80% alcohol solution. And 60 plus 40 is 100, so we know we did it correctly. All right, example 4. Two executives in cities 400 miles apart drive to a business meeting at a location on the line between their cities. They meet after 4 hours. Find the rate or the speed of each car if one travels 20 miles per hour faster than the other. All right, so for this, we need to use the distance formula. So distance is equal to rate times time, or D is equal to R times T. I'll write it as R times T is equal to D. The rate times the time is equal to the distance. So anytime you see the word speed, we know that we're talking about the distance. Okay. Other thing that you need to know is that if the vehicles are traveling in the same direction, you subtract, and if they're traveling in opposite directions, you add. All right, so same direction, subtract, opposite direction, add. Anytime you see a problem where you see the words speed, of course, we're using the distance formula. And then anytime they say that they're meeting, pay attention to what direction they're coming or going. All right. All right, so let me just give a little example before we actually do this one. Okay, so for example, let's say you have two cars that want to meet in Prattville. One car is coming from Birmingham, and the other car is coming from Montgomery. And they're going to meet in Prattville. So that means the car coming from Montgomery is traveling north, and the car coming from Birmingham is traveling south. That means that they are traveling in opposite directions, so you would add, if that makes sense. Okay, so opposite directions, add if they're going in the same direction. So let's say two cars leave Montgomery and they're both going to Prattville, then that means they're going in the same direction, and you would subtract. Okay. All right, so for this question, it says two executives in cities 400 miles apart drive to a business meeting at a location on the line between their cities. They meet after 4 hours. Find the rate or the speed of each car if one travels 20 miles per hour faster than the other. All right, so these two cars are going in the same direction, so we would subtract. So the first equation would be x minus y. Well, let's do this first. Let's say what is x and what is y. Let's let x be the fast car And let's let y be the slow car. Okay, because it says that one car is going 20 miles per hour faster than the other. All right, so since they're going in the same direction, we subtract. So x minus y is equal to 20. One car is going 20 miles per hour faster than the other. So the difference in the two speeds would be 20 miles per hour. All right. Now, rate times time equals distance. What is the rate? What is the time? Okay. It says they meet after 4 hours and the distance is 400 miles. So the time is 4. The distance is 400. And then the rate of the two cars. So we'll add those together. Okay. What I would do at this step is, because 400 is divisible by 4, you could actually just go ahead and divide both sides by 4 instead of distributing. So I'm going to rewrite these equations. So you would have x minus y equals 20 as equation 1, and x plus y equals 100 as equation 2. And now we can easily do elimination. So add the two equations together. And we get 60. All right, so now we can plug that into equation 1 or 2. I'll plug it into 2, which is x plus y equals 100. So 60 plus y equals 100. Subtract 60. And we get y is equal to 40. So that means that the fast car is going 60 miles per hour. And the slow car is going 40 miles per hour. Okay. I almost feel like I need to do another one like this. Oh, example 5. Okay. All right, so it says a plane flies 560 miles in 1.75 hours traveling with the wind. The return trip against the same wind takes the plane 2 hours. Find the rate or speed of the plane and the wind speed. So again, let me point this out, that if you are traveling with the wind, you add and it could be wind, it could be a current, but if you're traveling with it, you're going to add. And if you are traveling against it, you would subtract. You may also see questions where it says uphill and downhill. If you're going downhill, you would add. If you're going uphill, you would subtract. So just think of it like resistance. If you're going with something, it's easier to do, so you would add. If you're going against something or going uphill, it's harder to do, so you would subtract. All right, so we see that word speed, so we know we have to use the distance formula. So rate times time is equal to the distance. All right, so it says that the plane flies 560 miles in 1.75 hours traveling with the wind. So we're going to have two equations here. One where we're going with the wind and the other where we're going against the wind. But let's first identify our X and Y. I didn't do that. Okay, so let's let X be the rate of the plane. And let Y be the rate of the wind. All right, so again, I like to let X be the faster thing or the greater thing. So the plane would be traveling faster than the wind, I would hope. Okay. All right, so again, we'll have two equations, one where we're going with the wind and one where we are going against the wind. So if we're going with the wind, we add. So using the distance formula, rate times time equals distance. That would be 1.75 times x plus y equals 560. And then 2 hours, so 2 times x minus y equals 560. All right, so the time is 1.75 hours when you're going with the wind. So that's rate times time. And then the total distance is 560. The return trip against the same wind takes 2 hours. So time is 2. Rate you would subtract because you're going against. And the distance is still 560. So that's how I got my two equations. If you can go ahead and divide both sides, I would do that first just to make it easier. So if I can divide both sides by 1.75, I'll do that, and I think I can. And I'll divide both sides by 2 and get two new equations. So let's see, 560 divided by 1.75 is 320. So it does go in evenly. That helps us out a lot. So x plus y equals 320 is equation 1, and x minus y equals 280. Okay, so now we can do elimination easily because the y's would cancel out, and we get 2x is equal to 600. Then divide both sides by 2. And you get x is equal to 300. Then you can plug that back into either equation. I'll plug it into equation 1. So 300 plus y equals 320. Subtract 300. We get y is equal to 20. So the speed of the plane is 300 miles per hour. And the speed of the wind is 20 miles per hour. Okay, and you can check it. You can ask yourself, is it reasonable? Yes, it is reasonable for a plane to be flying a whole lot faster than the wind. If your wind is greater than your plane, then you're going to have trouble. All right. All right, one more example. This is not an example in your book, but you will have a homework problem like this. So I'm going to make up my own example 6. Okay, so this is really easy. The sum of two numbers is 16. Their difference is 6. What are the two numbers? So here are our two equations. The sum of two numbers is 16. X plus y equals 16. And their difference is 6. X minus y equals 6. We can easily do elimination because the y's will cancel out. And we get 2x is equal to 22. Divide both sides by 2. So x is equal to 11. And then you can plug that back into either equation. I'll plug it into equation 2. 11 minus y equals 6. So we get y is equal to 5. So the numbers are 11 and 5.